So again, in big square, I inscribe small square. Each side of this triangle is small a and big B. I can easily find width of this square. Width of this square, I put here arrow with this. This width is B plus A or A plus B, doesn't matter. So this A plus B, since this is square, and this A plus B. I can do it without writing, but I want to make this picture. And this A plus B. This is easy. If you combine two pieces, total would be A plus B. A plus B. So far, so good? Everybody understand. Is one piece is A and second B, total is AB with sign plus. Like if I have two markers, this black and green, if one is A, second B, total A plus B. Any questions, students, for this step? No questions. Let me make one more step. I will name this side of this small square. Let's say C, 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 and C. So you have everything of this. You have side of base, side of top. Now, based on our topic, area, I can write that area of square equals side by side, or side to the second power, right? For instance, if you have square and side equals to 5, area would be 5 to the second power, 25. Yes? If I have square side of 6, area would be what? 6 to the second power, 36. If I have side A plus B, area would be A plus B to the second power, right? Yes or no? I can write here area of this large square, step number 1. Area large equals A plus B to the second power. Side to second power. To understand this simple step. Who does not ask me question? Everybody. Good. Let me do from another piece, from step number 2. If you look at this picture, you can find that area of large triangle, area of large square, area of large square, this is square, equals area of small square plus area of 4 triangles. It's like you were small kids, you play with puzzles. You put pieces together. If you put together puzzle, right, you will get, look at this. If I have this plus this for triangle, I get the same area. I can write area large equals area small square plus 4 areas of triangles. Again, area small square plus area of 4 triangles. So far, so good? It's like kids' puzzle. When we were pre-K, you play around with these puzzles. You put together and you get this this idea. Any questions, students? No questions. Okay, let me make more details. How to find area small? Area small is C to the second power, since side equals to C. c to the second power. How to find area of one triangle? A times b divided by 2. A times b divided by 2. And multiply by 4. 1, 2, 3, 4. What is written here? Area of large equal this area small for areas triangles. So far so good? And we practice with you a lot with area of triangles.
Dr. Farber, at number 2, did you say plus 4 multiplied by a area of triangle?
Yes. It means 4. It means I have to, instead of writing 1 plus 2 plus 3 plus 4, I found area of one triangle and multiply by 4. Because it's 4 triangles. So far so good. For the same triangle, we name it congruent triangle. Did I answer your question?
Yes.
Good. Now, students, like we did in second grade or third grade, you simplify. 2 goes into 4 2 times. And I can override this equals c squares plus 2ab. What I did, I just simplified by 2. Any questions? If you don't have any question, look at this. This is area of a large square, and this is area of a large square. It's like in previous problem with triangles, this is the same square. Area must be the same. I can make equality. This piece equal to this piece, because we're talking about the same large square. So in step number 3, I will write a plus b to the second power equals c squared plus 2ab and plus, that's it, c squared plus 2ab. What I wrote, I take different color. I made this and the same. This equals to this. Why? Because it's the same what? Square. And we started with you a bridge formula. Who will remind you formula a plus b to the second power? We did it many expanded form. Somebody.
A to the second plus 2b plus b to the second.
Excellent. A to the second continually plus
2ab
plus 2ab
plus b to the second.
plus b to the second. Excellent. We did it and you're familiar. Let me just apply what Oleg said. All right, here. A to the second plus 2ab plus b to the second equals c squared plus 2. Yes. Okay, Maria, closer to microphone. I can hear you. Closer to microphone, please. Say it again.
Sorry, I was accidentally unmuted.
Okay. Well,
Sorry, I was accidentally unmuted.
yes. What is the question? Okay, no questions. Now, what I did, I just applied formula what Alex said. We know this. Now, take a look. We can combine like terms. Look at this. I subtract 2ab from here. I subtract 2ab from here. Cancel out, cancel out. And what is left? A squared plus b squared equals to c squared. I put in a red frame. And let's analyze what is it. let's say I denote one triangle is A. Oh, I put like this. Doesn't matter which order. A, B, C. This right triangle. So in right triangle, you see A to this. What we prove? We prove outstanding theorem, which was created 2.5 thousand years ago, 2,500 years. Can you believe 2,500 years ago by great genius, super great genius. His name is Pythagorean. And he found this relationship. What we did his steps pretty much. And they just proved Pythagorean theorem. According to Pythagorean, if you have any triangle, right triangle, any right triangle, and this angle is 90 degrees. If one side is A, doesn't matter which side, another is B, another is C, always for right triangle, A squared plus B squared equals to C squared. It was proven 2,500 years ago by Pythagorean. Pythagorean was a genius, definitely. He was born in island Samos in Greece, and he loved sport and math, and he loved philosophy. And I was very surprised when I read his books about him in childhood. He was not only a great mathematician, he was Olympic champion in boxing. Yes, it's true. He was Olympic champion in boxing. He was very healthy. He did sport. And he created this outstanding theorem. Now we use the theorem everywhere in our life. Many years ago, before Pythagorean, people knew some relationship from the theorem. And sometimes I'll tell you about ancient Egyptian. Ancient Egyptian cannot be pyramid without the theorem. Pyramid. I'll tell you how it works. Look at this. If you have, it works for any values. Let's say it could be fraction, decimals, or whole numbers. But if you have, let's say this is 3, this is 4, and this is 5, and the right angle. Apply this theorem, 3 to the second plus 4 to the second. You can see this equals to 5 to the second. Really, 3 to the second is 9. 4 to the second is 16 equals to 25. And 25 equals to 25. So one of example of triangle, very famous triangle, with whole numbers, which satisfy this Egyptian relationship, is 3, 4, 5. Ancient Egyptian, they knew this, and we name it Egyptian triangle. How can you use this relationship to build a pyramid? I present this Egyptian pyramid, square pyramid. Okay, Egyptian pyramid. But it's much bigger. For instance, Great Pyramid of Giza, it has this side about 238 meters, gigantic. You imagine 238 meters. And height of pyramid is about like skyscraper, 150 meters, gigantic. They were built from 3,000 to 7,000 years ago. this pyramid. Even now we have some secrets how they did it. We don't know exactly what they did, but imagine it was a lot of slaves who work in desert. But imagine you need to build this pyramid in desert, right? Before to build, you have to have a drawing of this square. Okay, if you make angle not right angle, Pharaoh would not like you. So what you build for me? Angle supposed to be perfectly right angle. How can you build right angle in desert 5,000 years ago? I asked one student in lecture how you will do this. He said, easy, I would use laser. Laser. You know laser, special devices in construction? Laser.
Yes.
Can you have laser 5,000 years ago?
No.
No. I tell you secret how they did it based on this relationship. Okay. Okay. They took a long rope, much bigger than this one. After that, they measure the speed by equal pieces. And they made knots. Equal pieces. One, another, and equally. Equal distance between them using knots. Узлы. And all distances were the same, exactly the same. They measure. They measure 10 times before to make these knots. After that, they went to the desert. And according to their religion, they put line on the desert, on the sand, directed to east. East. Let's say this is east. To build line in the desert is not difficult. After that, they took this rope and they took rope and got stick in the sand, big stick. This stick, pretend stick in the sand. After that, they measured this rope and they put here, let's say, they measure these ropes and they measure some, use ruler, this one. Okay, and they make, pretend this is 4 knots here, and they make this line, arc. They put second point, this is A, this is B. Okay. Now, they measure 3 knots. It's about, in my ruler would be about 15. Okay. All I have to do is make it a little bit bigger. Let's make bigger. Measured, it's supposed to be 5 pieces. Exactly 5. If you build it nice. So that's how they build this pyramid. After that, when they get right angle in the desert, they build another right angle. They connect it like this, and they start building pyramid. Because in the base, they get a square. Behind the scene, we have Pythagorean theorem. So far, so good. So we name this 3, 4, 5 Egyptian triangle. In our course, we name it Pythagorean triples. Triples. All, if you have 3, 4, 5 triangle, you can multiply by any numbers. For instance, 30, 40, 50. It's also related to this Pythagorean theorem. Multiply by 5 by any number. All these Pythagorean triples, they are derivative for 3, 4, 5. In our course, how many Pythagorean triples we have? We have infinite set of Pythagorean triples. Just for curiosity, I wrote a program in Java, and system worked and give me like millions of different Pythagorean triples automatically. I printed it out. I have some in my office days. But for us, we don't need to memorize a lot. My idea, not memorization. I give you just few Pythagorean triples what we need. Pythagorean triples. Okay. Next subtopic is Pythagorean triples. Write it down. For instance, 3, 4, 5. Or 5, 12, 13. How to see these Pythagorean triples? Look at this. 3, 4, 5, we check. Let's say this is 5, this is 12, this is 13, and we check. 5 to the second plus 12 to the second. Is it equals to 13 to the second? 5 to the second is 25. 12 to the second, 144. 13 to the second is 169. If you add them up, you get 169. Beautiful, it works. I give another Pythagorean triples which we use in our course, 8, 15, 17. Next is 7, 24, 25. Or 9, 40, 41, etc. I don't ask you to memorize. 3, 4, 5, everybody knows. This is basic. But if you know a couple more, it's not bad. It helps you to find faster relationship triangle. So based on this, if let's say I have triangle, look at this. This is 30. This is 40. What side is it? Hypotenuse? What? Tell me.
50.
Yes, it's the same like I multiply by 10 everything. Derivative of this, 50. Many questions on many tests based on this idea. When in Mount Palomar,
Dr. Farber, how did you get 50 for the hypotenuse?
look at this. I can do it two different ways. Either longer way, I use Pythagorean theorem. Look at this. A to the second plus b to the second, supposed to be e c to the second. Let's say forget about Pythagorean triples. What I'm doing here. I put 30 to the second plus 40 to the second equals 900 plus 1600, which is 2500, and this equal to c to the second. How to find c? We start with your irrational equations, take square root of both parts, and you get 50 equals to c. And I got 50. But instead of doing this way, when you know Pythagorean triples 3, 4, 5, and you know wherever you multiply this by any value, you get the same Pythagorean triples, the same relationship between them. If it is, I will multiply by 10 because this is 30. I'll get 30. I multiply by 10, this is 40. 4 times 10, 40. And this would be 50. Because if you multiply one side, you must multiply another side by the same value. So you have two ways. Either use Pythagorean theorem, or you can do it shortcut, faster. Because on the test, you have 1 minute 30 seconds for a problem, and you don't have luxury. You have shortcut, do shortcuts. Did I answer your question? Did I answer?
Yes.
Yes. So two ways, either use straight Pythagorean theorem, which is great, or from this Pythagorean theorem, we already counted and they found group of numbers which satisfy this Pythagorean theorem. Okay, the idea is so powerful. King of mathematician, non-officially king, but king of. You remember who took my Mark Twain prep many years ago? Okay, many of you, right? Do you remember we studied with you Gaussian method? Gaussian method when you add sequences 1, 2, 3 up to 100. Who remember Gaussian method? Yes, I told you a story about Carl Friedrich Gauss when he was in the first grade and he loved math. In order to keep him busy, teacher gave him a problem, add all numbers from 1 to 100 in sequence. And he did it instantly. He found the way how to do this. And now we use this method. We name it Gaussian method. Meanwhile, he became famous mathematician, probably #1 in the world. And he non-officially is a king of mathematics, Carl Friedrich Gauss. And he believed, he lived in 19th century, and he believed that not only not only people smart on the earth, there's some extraterrestrial civilization in different planets. And he expected that some people from space will visit us one day. And he wanted to create a way to tell these people, not people, to alien, that people here or creatures who live on Earth, they smart. And now what his idea was? He said, well, in Siberia, we have a lot of forest. We name it taiga. And he said, let's build a gigantic triangle if you cut some trees. Gigantic triangle with one side is 300 miles, another 400 miles, and another one would be how many miles? Tell me.
500.
500 miles. If you build this gigantic triangle in Siberia, in taiga, name taiga, and people from Mars, Martian or some alien people, they can see in telescope and see, wow, they know Pythagorean theorem, they're definitely smart. It was 19th century. In 20th century, when a nice radio telescope was built in Mount Palomar in United States, they decided to create a way to communicate with extraterrestrial, this civilization. And they decided to send them signal. You can write that I'm very smart in this signal. You have to decode something. And you know what they decided to do this? They decoded Pythagorean theorem. 3 signals, 4 signals, and next supposed to be what?
5
signals. 5.
And they special telescope send in universe signals 3, 4, 5, like this. And somebody will decode it. You know, light move with 300,000 kilometers per second. They decode it, found, wow, in the Earth, smart creatures live, and they visit us. So Pythagorean theorem is like a business card, was probably for Earth. It showed that you're a really smart civilization. Everybody knows Pythagorean theorem. He loved boxing, he loved sport, right? And it's example for many young kids to study math and doing sport. Okay, I show how you know how he look like. Let me show him. Okay, here it is. How he look like. Pythagoras. You see Pythagoras?
Yes.
And this he got an Olympic, this one, for boxing as well. I show another way, if I find it right now. Just a second. Here it is. Look at this, how he looks. First of all, you can read this. Can you see this Pythagoras? It's actually written in Greek, but this is Pythagoras. This is him. And if you look at what he holding this papyrus, I don't know, you see this or not? You see this triangle?
Yes, it says ABC, right?
A squared plus B squared equal to C squared over there. See this? Over there, beneath.
Yes.
And what he built here, this famous picture, I'll show this picture. He built a triangle like this. Let's say build this triangle ABC. Okay, this is, let's say, B, this is A, this is C. And idea is, if you build a square here, C, like we built this square C, then this is square. And this square is B, all sides B. And this side is A. And you roll this Pythagorean theorem. It shows square of this, area of this is area of this, equals to area of this. Okay. If you put it back, put like this back, it look like pants. That's one in Russia. I believe majority you know Russian. We have expression. Пифагоровые штаны во все стороны равны. This is some joke, but this idea. If you take this to the second, equal this to the second plus this to the second. It looks like pants. Okay. I can talk about him more and more, but he gave me inspiration to do sport. And I, after I read this story, I decided to, in parallel with math and science, to be in sport. As a result, I got master degree in wrestling and weightlifting. And I practice boxing a lot. Why I'm telling about this is help you. I even work like a trainer in wrestling weightlifting for 8 years. My point is, you have a parallel to study math and sport and science department. It gives you inspiration. Well, let me put it back and we'll see how we can apply these ideas for solving your test problems. Now, everybody knows this relationship. Everybody knows Pythagorean triples. I will write this over there and erase everything. Let me summarize what we have for our lesson. Write on the right part, and one more time. On the back of your notebook, 5 pages before the end, my suggestion, write it down. Some important relationship. A squared plus B squared equal to C squared. Next, few Pythagorean triples. 3, 4, 5. 5, 12, 13. 8, 15, 17. 7, 24, 25. We don't need it too much, all of them, but I just wrote some example. Again, we have this, I make a little bit indentation because this must. This, if you know, this is good. If not, it's not necessary. And now we solve few problems together with you. Okay. First of all, I solve by myself. For instance, I have a triangle. I have a triangle. Let me find this one. You have many examples of this. For instance, one example. I'm looking for easy example at the beginning. Okay, let me create one myself. Example number one. We have a triangle with small numbers at the beginning. Let's say this equals to 5, to equals to 6, this equal to 3. Find this side, triangle ABC. In math, it's convention. We name vertices by capital letters, and opposite of this vertices side is small. This is C small, this is B small, and this A small. And assignment is, this is right triangle. You have to find x. According to Pythagorean theorem, you can write x to the second equals 3 to the second. I just wrote different order. It's more convenient. Plus 6 to the second. So far, so good. Questions? No questions. 3 to the second is 9. Plus 6 to the second is 36. Which equals to 45. And what we got? We got x to the second equals to 45. Since side's not negative, you know x must be positive. You take square root of both parts. And this would be x. And how to simplify square root of 45? Extract the greatest perfect square, which is 9 times 5. And you know formula that square root of product equal product of square roots. And square root of 9 is 3 times square root of 5. This would be the final answer. Now we see we use this quadratic equation. We use chapter 10, operation with radicals. Everything that we build right now is very helpful to solve these geometric problems. Ask me any questions if you have. No questions? Okay.
No.
Not difficult, right? Let me create example number 2. Okay. Let's say I have another triangle. I made up some numbers, which is 10, and this is 5. Find this side. According to Pythagorean theorem, x to the second plus 5 to the second equals to 10 to the second. So far, so good? No questions?
No.
Keep doing. X squared plus 25 equals to 100. We have quadratic equation. Only difference, we never use here negative numbers for this particular case, because usually you have to use plus minus. But in some situation, you have to consider different value. You know, side only is not negative. That's I consider only plus. Minus 25 and minus 25. X to the second cancel out equals to 75. You take square root of both sides. Square root of x to the second is x. 75 is square root of 25 times 3. But square root of 25 is 5. Square root of 3. Check mark. Always simplify, otherwise you'll not find in multiple choice this answer. Okay, I show when we have two legs. I remember a joke. It's not a joke. 2 years ago, I had a wonderful student, one girl, and I explained this. I said, this is a leg. She forgot how we name it. And I said, this is leg. And how this? She said, this hypotenuse. And what is it? She said, this is hand. If this is leg, this is hand. No way. Leg and leg. Leg and leg. And hypotenuse. I'll show a nice picture we did. We built a clone. I don't have this picture right now, but pretend this is a clone. And he just resting on the grass with this. And this one his leg, this another his leg, and this hippopotamus here, somewhere. Hypotenuse. Leg, hypotenuse. So we found hypotenuse when two legs are given. We found a leg when hypotenuse, a leg given, using Pythagorean triples. And it's not difficult. This is beautiful Pythagorean theorem behind the scene. Okay. Can you imagine 2.5 thousand years ago? And ancient Babylonian, before they knew this theorem, or not this way, but they I saw some books where have this made of clusters, different stones, where the ancient Babylonian used the same ideas 7,000 years ago. This is how it works. Now, I want to go through some questions to help you to do homework. If you have any question, ask me without hesitation. If you don't, I show a few examples. For instance, this one. Example number 3. Example number 3. Let's say you have a square. This is a square given square. And one side of this square, let's equals to 4. Side of square. And they ask you to find diagonal. A, B, C, D. Find diagonal. A, C, question mark. Well, even though this is a square, Step number one, you clearly see that ACD is right triangle. If right, you can apply theorem, Pythagorean. A to the second plus B to the second equals to C to the second. Oh, imagine this is A, this is B, they're the same. I can write 4 to the second plus this is C, or diagonal, plus 4 to the second, which is equals to C to the second, or 16 plus 16, which is equal to 32, equals to C to the second. Let me write it convenient way. C to the second equals to 32. Take square root of both parts. Square root of C to the second is, or you can use X, whatever you like, or D diagonal. This is C equals. But it's, you never find this in multiple choice. Use chapter 10. Extract the greatest factor square, which is 16 times 2. Square root of 16 is 4. Square root of 2. And we found diagonal of square based on Pythagorean theorem. So far, so good. Questions? Ask me questions.
No question.
Who understand everything? Raise your hand. Keep in mind, Pythagorean theorem is not this beautiful theorem. It's business card of our civilization. Okay, it is.
Mr. Farber,
Yes.
can you put a check mark?
Yes. Agree. And you can put smiley face if you'd like. Okay. Let me give another one. Few examples. Now, you ready for homework? And I do, Georgie, don't find in multiple choice anything because I give you my numbers. Similar problem, but my numbers. You understand this? If you're trying to find multiple choice, you never find because I give you my numbers, but the same idea. Let me read everything and we prepare for homework. Okay, let me make a similar.
Dr. Farber, can we try solving one on our own?
Not right now. First of all, I will not have time to explain your homework. If you have spare time, you will. Make sense?
Yes.
Because we have many questions and I want to be sure that you're confident with this. Okay. Who will read problem number 1? Exercise 3, number 1. Read somebody. Okay. Who is ready? Mubina, please. Exercise 3, number 1 from your package. Can't believe it. You can read?
A farmer uses 140 feet of fencing to enclose a rectangular field. If the ratio of length to width is 3 to 4, find the diagonal in feet of the field.
Okay, let's do this. Thank you. So, but I changed numbers. Number would be different, but idea is the same. Let's say we have a rectangular field. Problem number 1. It's 3, 1, 8. It means Dr. Farber's problem. I make this rectangle And ratio of length to width equals to, I make it 6 to 8. So this side is 6x and this is 8x. Why use x? Because 6 to 8, maybe it's 12 to 16. You always use scaling factor. Okay. Next. And left side is left side equals to 420. Perimeter equals to 420 people. They ask you find diagonal. So this is 8x, 6x. They ask you to find diagonal. A, B, and C. First of all, from first grade, you know, step number 1. Perimeter equals 2 length plus width equals 2. Length is 6x. Width is 8x. And equals to 420. Or 6x plus 8x equals to 14x. Okay. Times 2, you have 28x's. Equals to 420. I step back. If you have any questions, ask me.
Dr. Farber, why do we need to find the perimeter?
Read this problem again, please. Read this problem. I saw your homework. Read out loud, please.
A farmer uses 140 feet of fencing to enclose a rectangular field. If the ratio of length to width is 3 to 4, find a diagonal in feet of the field.
You got the answer, Oleg? Because perimeter is given. Well, did I answer question?
No.
Read it again. I explain again. Always not too fast. Just slow with intonation, please.
A farmer uses 140 feet of fencing to enclose a rectangular field. If the ratio of length to width is 3 to 4, find the diagonal in feet of the field.
But perimeter, they said, use 140 feet of fencing. What is whatever? One fencing is perimeter, is around this field you have a fence. The bigger perimeter, the bigger diagonal. If you have small field, you have small diagonal. If you have bigger field, you have bigger diagonal. It's given. When you prepare soup, you use all these ingredients given. This is given. I write here, given. I explain again, Oleg, this way. If you have ratio, you have no idea about what big is it x, because I give example. Look at this. This tiny also has 6x, and this is 8x. Or this one also 6x, 8x. To find value of x, you're always supposed to get length of this fencing around. Because ratio shows similarity. And you're supposed to get exact value. Let me finish after that explain again. Look at this. What I did, I wrote the expression in terms of x. I want to find scaling factor. What value is supposed to multiply this x's to get to 420 feet. From this simple equation, when you divide by 28 both parts, I found x equals to 15. If this is 15, this side, Oleg, equals 6 times 15, which is 90 feet. I actually even don't need this. And this equals 8 times 15. Okay. Now I found real sizes of my field. So far so good. So if you multiply 8 by 15, you have 120 feet. The next step, when you have real sizes of this triangle, you have to find diagonal. Two ways. Either use Pythagorean theorem or see if it's Pythagorean triples. Look at this. For me, 90 feet is what is it? Is 3 times 30. What is 120? 120 is the same like 4 times 30. You see 3, 4, 5 Pythagorean triple? Based on this side supposed to be equals to, who help me? If this side is 3 times 30, this side is 4 times 30, this one, how long this supposed to be?
150.
Yes, 5 times 30, which is 150. Is it possible to find without perimeter? You will not know the value of this length. Either this big, or this big, or this big, or maybe gigantic. So before this, like we did in 4th grade, you have to find sizes, dimension of this triangle. After that, apply either Pythagorean triples or Pythagorean theorem. Look at this. Yes.
Why do you use 3x and 4x?
Why use what?
Why can you use 3x and 4x?
You can use 3 and 4x, but you will not find, if you have 3x and 4x, it would be 5x. But this is not the answer. How you find the amount of feet? How you find the real length? Now I understand why I don't use 3x and 4x, because this is not problem I solve for you. You understand this? This is my problem. This is different problem. I change numbers. I don't know. Do I answer question?
Yeah, you did.
I deliberately change numbers. Students, I give you rod, and you have to catch fish, not Dr. Farber for you. Я даю вам удочки, ловите рыбу сами. Make sense? I teach you to think. I changed
Yes.
this. I took this problem, I changed number completely, but I give the same idea. And based on this, you will solve this number. I always do like this. I never solve homework for you. Now I understand your question. So keep in mind, every time I change numbers, it's my numbers, not book's numbers. Ask me questions if you have for this, Nicole. Pretend I forget this. Pretend I forget Pythagorean triple. So what? Look at this. This side is 90. This side is 120. I want to find AB. AB is second way. The second way. AB to the second equals 90 to the second plus 120. I don't confuse with 8. 90 to the second is 81 into zeros. Uh, 12 to the second is 144 into zeros. Add them up. 0, 0, 5 to 25. Square root of AB to the second is square root of this one. Square root of 225 is 15. Square root of 100 is 10. You get 150. You get the same answer using either Pythagorean theorem or Pythagorean triples. Pythagorean triples save your time a little bit. Sometimes a lot. Okay. At home, you do the same problem with different numbers. Just practice more. Okay, number 2. Number 2. Read problem, somebody. Number 2.
Can I read?
Yes, please.
Find the altitude of an equilateral triangle whose sides is 20.
Okay, thank you very much. Let me do this with you. Only change numbers. Number would not be the same. Later, I show a few different ways how to do this, but today our topic is Pythagorean. I explain how to use it. When you read a book at home explanation, they give a lot of number multiply, memorize. Don't memorize anything. You don't need garbage. Just try to understand logic. So 3 to A, it means my problem, not your homework problem. Make a triangle. Which triangle they ask you? Equilateral triangle. Equilateral triangle, all sides are the same. There's A, B, C. So make altitude. And this is X. Okay. I change numbers. For instance, it was 40. I make you easy numbers. Something like this. Let's say 20 or 80 or 16, whatever you have. Left side of this triangle is, what do you have again? 40 or 20? Oh, they have 20. Okay, pretend this side is 14. This is my side, 14 inches, let's say. And you know, equilateral triangles, all sides the same. Agree? This is definition of equilateral triangle. Next, you know, this is a symmetrical picture. Altitude in equilateral triangle is median and bisectors. It means they split this side by 2 the same sides. So this piece is 7 by half, and this side is 7. So far, so good. Next, A, B, C, D. Triangle. A, not A, use B, C, D. Is right triangle. Right triangle. If right triangle, apply Pythagorean. A squared plus B squared plus equals to C squared. A squared is 7 to the second. B squared is x to the second equals to 14 to the second. I step back. Ask me any questions if you have. Who understands this 100%? Okay. Quadratic equation. 49 plus x to the second equals to 196. Minus 49 and minus 49. Cancel out x to the second and subtract these two numbers. After subtractions, what are you getting? 147, right? What is 147? is 49 times 3, I believe, right?
Yes.
Take square root, simplify it. Equals to 49 times 3. And you have x. Square root of 49 is 7 times square root of 3. If you have question, ask me.
What are we trying to find in this question?
Read this question again, Andrei. Read question number 2. Out loud, please.
Up to 4 Bible question.
No, Omar, wait a second. Respect each other. Andrei, read out loud this problem. Number 2. 3-2. I can hear you, Andrei.
Oh, sorry, I was muted. Find the altitude of an equilateral triangle whose side is 20.
Okay. I change problem. My problem is find altitude.
Oh, altitude, okay.
Altitude is height. But I changed sign. Instead of 20, I made up, let's say, 14. Ask me more questions if you have. Did I answer question, Andrew?
Yes, thank you.
Umar, what is your question? Umar, question mark.
Yeah, sorry, that's forever. How in the like step 3? How'd you get 14 to the power of second?
Is given. I put each side is given 14. I change number to 14. Every side equilateral. Equilateral.
Oh,
All sides equals 14. It's given. I just made up.
Dr. Farber, can we do 3.5?
What do you
I
mean?
change the numbers.
What is this 3.5?
It asks us to find the length of D and B.
You mean example 3.5?
Yes.
Sure, we can do this. Let me go 3.5. It's not 3.5, 3.5, because I thought that you asked me about decimals. 3.5a, but I changed numbers for you, okay?
Okay.
3.5a. I read this 3.5 in this version that you have, please.
Find the length of DB.
Oh, it's it. Okay, nothing to read too much, right? Make a picture again. 3.5. This right angle. This A. CD, I use the same letters. This is X. This is B. Let me try to. I change numbers. I will not use the same numbers again. Let's say I will use different numbers. Let's say this is 30. This is 34. This is 50. Okay. And you have to find dB. Okay, good. Let me do this with you. I'm looking if I change number correctly. What is 34? I use red color. Try to follow me. I'll do step by step. Look at this. I start from triangle ACD. Step number 1, triangle ACD is right triangle. Okay, I take red color and I represent 34 like 17 times 2. 30 I represent like 15 times 2. Look at my Pythagorean triples. To save time, you can use Pythagorean theorem, but this is 8, 15, 17. Can you see this one? So if this is 15 times 2, this 17 times 2, this side must be what?
8 times 2.
8 times 2. Beautiful. In one shot, we found this side equals to 16. Aha. From this, we found CD equals to 16. Because we have 8, 15, 17 Pythagorean triples. If you forget, use x, and from quadratic equation, find this side. Like we did before. Next, I go to triangle ACB. This is right triangle. In this triangle, if you look carefully, look at this picture. We have this, I take different color to visualize. What is 50? Is 5 times 10. What is 30? Is 3 times 10. Aha. So based on this side is supposed to be what? Help me.
4 times 10.
4 times 10. Excellent. 4 times 10, which is 40. Why? This is this Pythagorean triple, 3, 4, 5. And the very last step. The very last step, step number 3. If this is 40 and this 16, x equals, you can write like equation x plus 16 equals to 40, or minus 16 and minus 16, x cancel out equals to what? 24. Isn't beautiful? 3 steps.
I don't understand.
Ask me a question.
I just don't understand what you did here at all.
I explain again. Just try to listen carefully. So forget about this fancy picture, Oleg. You have triangle. One triangle, just one. And this side A, C, and D. In one side is 34. In other side is 30. I want to find this side. You can use either Pythagorean theorem, use x and find this, or look on set of Pythagorean triples. You have it, right? If you look at this, you can easily see that two numbers I said we have basic Pythagorean triples and derivative. If I multiply this by 2, Oleg, tell me what set I will get if I multiply each by 2.
16, 30, 34.
16, next one, what is it?
30.
30.
34.
Aha. So if I have 16 and 30, next is 34. If I have 30 and 34, next is
16.
Okay, but I have 30 and 34. What is next one?
16.
Beautiful. I know this is 16. Okay, good. Oleg, so far so good?
Yes.
Now, Oleg, second question for you. I make over the build. I build another. I have spare time over there, spare space. I have another triangle. Forget about this one. A, B, and C. And this side is 50. And this side is 30. You want to find this CB. What Pythagorean triples derivative it remind you this right angle? The first, second, third, fourth, which one?
First.
First. If you multiply everything by 10, what I'll get? Tell me, Eric.
30, 40, 50.
30, 40, 50. If this is for 30, 50, what is supposed to be here?
40.
40. Beautiful. I know this side, which is 40. I know this side is 16. Now imagine, Oleg, I have two markers. Okay. Overall, all together, this give you 40 and give you 16. How long is this green marker?
16.
Yes, you solve it under my supervision. You solve by yourself. So this is 16 minus 40 minus 16. I have 24. Whatever. How about this? No, Oleg. I want to finish with one student. Question mark? Ask me.
Oh. I don't have any question.
No question. No, somebody asked me a question. Yes.
What if one of the numbers in the triangle weren't divisible?
What do you mean not divisible? Use Pythagorean theorem and take square root of this.
Okay, thank you.
Welcome. My suggestion, students, definitely I can teach you addings of fraction like you do in your beautiful school. But will you win with this basic super knowledge? What do you think? You will win in this real life?
No.
No.
All my students who came from test, they do it like 1 to 3. Easy. Instead of 90 minutes, my student doing for 37 minutes and get perfect score. In the 37 minutes, they triple check. We made experiment a few days ago. We gave them SAT test, and average grade was 700 and up out of 800. 8th graders, and bigger than the test from 11th graders, STY Brooklyn Tech. That's why my point is, Oleg and everybody, from now I wanna enhance your English part as well. We gave example to relax a little bit, right? But English is 50%. Tons of people call us to, they were not happy with English in the United States on these classes, except of my student. They did it easily, not easily, but they were very confident. Only one thing, if I give you easy, I give you a little bit, I step back with Dr. James with English. I give you a little bit easy exercises, but now, nothing personal, but you have to, in order to win, you have to work harder. You understand, students? I have tons of examples for tons of samples for easy one. Will you win with easy example, students? What do you think?
No.
No.
Never. So that's why, in order to win, nobody promised you easy life. I give a little bit reasonable. I don't give a very advanced stuff. I have a group for Harvard Olympics I prepare, absolutely different story. I give you reasonable, but you must be winner. All my students winner. From now, I give assignment manager and Dr. James. We created program together with him. And I created this program with Dr. Lemberg in 1993 in English. All people from entire New York came to our academy to study English, from private to whatever, because we have great idea about English. Because I study systems. Usually teacher who teach anywhere, they don't understand what is a system. My major part is a system vision. So from now, be ready. Your English would be more advanced. Not advanced, but a little bit more advanced, little by little. Okay, who understand? Raise your hand, English students. No complaint. In order to win, there is expression. Famous book Dale Carnegie. I'll tell you in Russian. Он говорит, что если вы хотите поймать рыбу, учитывайте, что любит рыба, а не то, что вы любите. Если вы любите ice cream, you never catch a fish. I translate. In order to catch a fish, you have to take consideration what fish likes, not what you like. And this is one of the best theorem in math. This is beautiful. Nothing is more gorgeous in math than this theorem. We have a lot of stuff, but this Pythagorean. Without any, he created his school, Pythagorean school, by the way, and he taught philosophy. All these students, they named Pythagoreans students. They study special philosophy. Okay, so from now, English also would be advanced. Keep in mind, English you will not pick up for one summer, no way. Or you go to nice school where not native people teaching, etc. You have to win. Keep in mind. Okay, good. Who understands this problem? 100%. What I did is just apply Pythagorean triples 2 times. I know we're out of time. If you'd mind to stay a few more minutes, I want to explain something else. Okay. Now, let me find some example. Read somebody problem number 4. 3-4. Who did not read today? Alyssa, please. 3-4. Can hear you. Exercise 3, number 4. Few more minutes, students. Alyssa, your microphone works or not? Aziza, 3-4, please.
Find the perimeter of a square whose diagonal is 6 radical 2.
Okay. Well, in future I solve you few. I solve this problem few different ways, but I will create this. Okay. I'll change numbers. Okay. Let's say I will make a square. Always make a picture first. Geometry is a language of picture. Square, and we have diagonal, and there's A, B, C, D. And let me make diagonal any numbers, let's say 10. And find perimeter. Find perimeter. So I made my numbers. This 3, 4, 8, Dr. Farber's 8. Well, to find perimeter, you have to find the side. To find the side, you have to use Pythagorean theorem. This in rectangle and square, all angles 90 degrees, and you can write a square plus b square equals to c square, or x to the second plus x to the second equals to 10 to the second. Combine like terms. 2x squared equals to 100. Not too fast?
No.
I just apply Pythagorean. Piece of cake. Next. Inverse operation is division. I divide by 2 both parts. 50. X to the second equals to 50. How to find, Katya, how to find x?
You take the square root of 50.
A plus. Good answer. x. Now represent square root of 50. Who will tell me how to represent square? Extract the greatest perfect square. Greatest perfect square. Who will help me with this?
25 times.
Yes, excellent. 25 times 2. And square root of 25 is 5 square root of 2. Check mark. Can I put check mark? No, I made mistake. Yeah. No. I found sign. This is not check mark. I found the sign. I need to find perimeter. I always do like this. 5 times 7, 37. They said, yes, you're not listening. Perimeter, the next step. This is step number 1. This is step number 2. Step number 3. Perimeter equals. How many sides we have in the square?
4.
4.
Equals 4 x's. Or instead of x, 4 times 5 times square root of 2, which is 20 square root of 2. Now you have right to put a check mark. So far, so good?
Yes.
Who understand up to this point 100%? Not 90, 100%. Who has question? Ask me questions. Vida, how you not raising hand? You understand 100%? Vida, why you use some software? Vida, Ivan. Okay, don't use software. Raise your hand again. Let me see. Who can hear me? Raise your hand. Everybody. Who can hear me? What about Alexandra, Albert? Raise hand. Good. This is good. You have to be careful, listen careful, okay? Don't sleep. So I explained this problem. Now the last problem left. Few more minutes for homework is problem number 3. I will create some problem for you very similar. Who will read 3? Somebody who wake up right now. Katya, please. Problem number 3. 3.
2 boats leave the same dock at the same time. One traveling due west at 8 miles per hour and the other due north at 15 miles per hour. How many miles apart are the boats after 3 hours?
Okay, excellent. Let's do this. 3. I read it. 2 boats leave the same dock at the same time. One due west. West is this way. This is west. And one due north. North is this way. So this is west, this is north. This is west, north. One is 8 miles per hour. Another one is 15 miles per hour. Let me change numbers for you. Let me change numbers. I will double it. Let's say this direction is 16 miles per hour. And this direction is 30 mph. Okay. And how many miles? It would be 338, Dr. Farber said. How many miles apart the house after 3 hours? Given I use 5 hours or 4 hours, whatever, 5 hours. Not the same number, I just changed numbers. Okay, look at this. From 4th grade, you know the formula. Distance equals rate times time. For instance, you run 10 miles per hour and you run 2 hours. Distance 10 times 2, 20 miles. I can easily find distance which cover this boat for 5 hours. So for 5 hours, d west equals 16 times 5, which is 16 times 5 miles. And d north, distance north, equal 30 times 5 miles. And pretend in 5 hours, this boat is over there. And in 5 hours, since this rate is smaller, this is bigger. So I make it like this, proportion kind of. Let's say this is point A, B, I'll make it consistent, C, A, and B. And this is this distance. And this is distance, this one. Okay. This distance. Let me read the question again. The question is, how many miles apart? They ask you to find distance between these two boats, A, B. So in this triangle, not to confuse, we have triangle. This 16 times 5. What is 16 times 5? It's the same like 8 times 10. 16 times 5 is 80, which is 8 times 10. What is 30 times 5? Is 150. It's the same like 15 times 10. We have this right angle because north and west they mutually perpendicular. And look at this Pythagorean triples. We have 8 times 10, 15 times 10. This must be what? Tell me, help me.
17.
17 times 10. 17 times 10, which is 170 miles. And that's it. This is beauty of Pythagorean triples and Pythagorean theorem. I give example not only with Pythagorean triples, I give example where you practice with Pythagorean triples and as well as Pythagorean theorem. You have leg, you have to find hypotenuse. You have hypotenuse leg, you have to find another leg. So far, I will send you this. I was supposed to prepare based on today's question. I send you more exercises based on this. So after my meeting, I have a few meetings right now. Later I send you, but meanwhile, not to waste time. What you're supposed to do? Redo everything for today. I will send this everything. Plus, you can start studying exercise 3, which we name right triangle. Right triangle. You have some explanation of this. Read first the explanation. Practice with examples. And they give you special triangles. My recommendation, you can read this, but don't memorize this stuff. You don't need this. My request, less memorization, more. You can solve this problem, but use Pythagorean theorem without memorization. The square root of 3, square root of 2, you don't need this stuff. When I teach you trigonometry, this goes from trigonometry. You have to know basic of trigonometry. I show how to get this number on your fingers. So no memorization too much, but solve all this problem introduction using our approach, Pythagorean theorem. Okay. And after that, you can start today before I send you. You can start doing this exercise 3. I solve all questions with analysis 3. before to do this, you must redo notebook, whatever I explain you, okay? Whatever I explain. Use the same approach, practice my exam a few times, after this homework. And now you understand what we did today. We cover great legacy of genius, which created a theorem 2.5 thousand years ago. And you see here is Pythagorean theorem. Now it's, you understand everything what is written in this papyrus, right? This is how he look like.
Yes.
Absolutely great idea. We study business card of our civilization today. Pythagorean theorem. Very good. Like it?
Yes.
Yes.
Great. Okay. Well, this is about it. Any questions about today's lecture?
No.
No questions. Okay. Be optimistic. Be strong. Be well. More practice, students, with all my steps. Few times you can cheat. Look at this again. After that, finally, do without any cheating. The same steps. Take care. Have a nice
Dr.
day.
Farber,
Yes,
you're going to send us what the homework is, right?
I will send you. But meanwhile, not wasting time, because what I'm doing, usually I need time from my millions of different sources. I have to find what I customize this class. If you compare every year of my studying from previously, it's not the same, never the same. I customize, even we study in group, I give you assignment customizing by this group, by personal
Okay,
questions.
thank you.
So,
Have a great day, Dr.
one
Farber. Bye.
question. I give you extra time. Why I give you extra time? I don't have spare time. I don't have time at all, but I give you extra time. We don't charge for this extra time because our goal is result. My goal is you're supposed to win. You're supposed to be appreciative and spend more time for doing homework. Now I explain everything. Enjoy math. Have a nice day. Take care.
Thank you, Dr.
Thank you,
Farber.
Dr.
Bye.
Farber. Bye.
Dr. Farber.
Bye.
Bye. Bye.
Bye.